Welcome back to the solution video of A and ACE level Mathematics paper 12, February-March 2024. Let's continue with question number 7. It says a straight line x y equal to x plus 5 and the curve 2x square plus 2y square 3y square equal to k. So maybe an oval or something like this. So it has some they said that they are meeting at a single point. So I'll have to undo this. That means if that is the curve, this is the line, that means it's a tangent. Find the value of constant k, this k. So since they are meeting at this point and the coordinates of this point, if they are x and y, this y is same here and here, this x is exactly same here and here at this point P. Okay, so what will we do? We'll substitute this y with its counterpart in linear equation x plus 5, and that will give us the point of intersection. So 2x square remains 2x square, but 3y square. In place of y, I will write x plus 5 and is equal to k. So let me open this bracket and we'll get a quadratic equation. So 2x square remains 2x square, but 3. If I open this, a plus b whole square, that identity I will use here, just like I used in one of the previous questions where trig identities were to be proven. So x plus 5 square will be x square, which is a square, plus b square, plus 2ab equal to k. So 2x square plus 3 x square plus 25 plus 10x equal to k. And let's open this and bring k to the left side. 2x square plus 3x square plus 75, 3 times 25 is 75, plus 30x minus k equal to 0. So 2 plus 3, 5x square plus 30x plus 75 minus k equal to 0. Now they clearly said that they're meeting at a single point. That means the solution of this equation will be only one. And when there is one solution, when there is that means discriminant b square minus 4ac will be equal to 0. So b is 30. Minus 4 times 5 times 75 minus k is equal to 0. Alright, and now we'll just open this up. 900 minus 20 times 75 will be 1500 plus 20k equal to 0. So 20 multiplies with 75 as well as k, and all of them. Okay, we can solve this. 900 minus 1500 is minus 600, and that minus 600 I'll take it to the right side, which will become positive 600. So k is 600 divided by 20, which is 30. We found the value of k. Find the value of constant k. We have found it. What does the second part say? Find the coordinates of p. Find the coordinates of p. That means if we can find x, we can find y also. And how can we find x? We got this equation, this one, yeah, this one we got as the intersection equation of the line and the curve. So it will be 5x square plus 30x plus 75 minus 30 equal to 0, which is 5x square plus 30x plus 45 equal to 0. All of them are multiples of 5, so let's divide by 5 whole equation, divide by 5, or individually you can divide by 5. So 5x square divided by 5, x square plus 6x and 45 divided by 9. And I can clearly see that it is again x plus 3 square. It's a perfect square. You can use quadratic formula, or you can split the middle term. You will see that you will get x plus 3 whole square. I can clearly see it's a perfect square. So it gives us x plus 3 equal to 0, or x is equal to minus 3. So we got x coordinate of minus 3 for P. This is minus 3. Now we have to find y. And for y, we can use either the equation of the line or the curve. And the equation of line is more suitable here. Very easy. Y equal to x plus 5. I will find y through that. Y equal to x plus 5 minus 3 plus 5, which is 2. So the coordinates of P are minus 3 and 2. Question number 8. A part. An arithmetic progression AP is such that its first term is 6. So A is 6, or A1 you can write it. And the 10th term is 19.5. Find the sum of the first 100 terms of this arithmetic progression. So what is the formula for the sum of n terms? Sn is n over 2, 2a plus n minus 1 d. So S100 we want, right? First 100 terms, they said. First 100 terms equal to 100 divided by 2, 2 times first term, 6, plus 100 minus 1 times d. And now d is the problem. We don't know d. So we can find through help of this 10th term. So A10, what is the formula for the nth term? An is equal to a plus n minus 1 d. So A10 is 6 is a, it will be 10 minus 1, and d is unknown, but it is equal to 19.5. That's what they're saying here. So 6 goes with 19.5, so it becomes 9d. 10 minus 1 is 9, d 19.5 minus 6. So we can divide both sides by 9. So d is 13.5 divided by 9, which is 1.5. So I can use 1.5 as d here now, and we'll find it. S100 will be 50 here, 12 plus 99 times 1.5 will be 148.5. So it becomes 50 times 160.5. That gives us 8,025. Yeah, decimal gone by 0. 8,025 is the sum of first 100 terms. Alright, GP A1, A2, A3 such that A1 is 24. So the first term is 24, and the common difference, common ratio is half. So it is also given. Very well done. The sum to infinity of this geometric progression is denoted by S. So let's find S. For this S, the formula for S infinity equal to A1 minus R, right? So they are saying that it is S. Sum to infinity is S. So we'll let S equal to, first term is 24, 1 minus half, which is 24, divided by half. And I will write 1 only here and multiply 2 up there, so 48. So S comes out to be 48. Okay. Next one. The sum to infinity of even numbered terms A2, A4, A6. That means the odd ones are out and their sum is SE. So let's say SE will be equal to A2 plus A4 plus A6 till infinity, but only even ones. So let's write what is A2 according to the formula of the nth term of geometric progression, an equal to ARn minus 1, and that's what we'll write here. A is the first term, R n minus 1, 2 minus 1 will be 1, so I'm not writing it. Then AR 4 minus 1, 3, then AR 6 minus 1, 5, plus AR 7, and so on. I take A common from all of them, right? So A is out, we are left with R, and R is given half. A is out, so R cube is left, so 1 over 2 cube is left, then 1 over 2 to the power 5 plus so on. Okay, now if you notice, this itself becomes a new geometric progression, this one, sum of geometric progression. Yes, so in this case, if I look at half 1 over shall I write 8? Okay, let's write 8, and 1 over 32 and so on. This becomes a GP where A is 1 over 2. Let me use U1 equal to half, and R common ratio will be 1 over 8 divided by 1 over half. Yeah, this term divided by this or this term divided by this will give you the same R, and which will be 1 over 4. If you put this in a calculator, you will understand it is 1 over 4, right? And now since they are adding here and they are adding till infinity, that means we'll use the exactly same formula for them as well. Okay, so A in the original series was 24, so I'll write 24, and then I'll use this formula where for the internal geometric progression, which is different from the original one, this one. A in this case is half, so I'll put this A as half divided by 1 minus R, and we got 1 R as 1/4 for internal one. Alright, so that comes out to be 24 multiplied by half, let's write it this way, divided by 1 minus 1/4 is 3/4. And let's complete here. 24 times, this will cross over, so this and this, okay, 1 over 2 times 4 over 3, so 2 and 4 cancel, 2 over 3 here, and this 3 will also cancel with this, so 8 times 2, 16 is SE. What are they asking? Find the values of S and SE. S was 48, SE is 16. That means if odd numbers were added, they would be 32. Here 48 minus 16, 32, but they didn't ask. We're good. Question number 9. The functions f and g are defined for all real values of x by this and this. This is quadratic, this is linear, where k is a constant. Given that the range of the function gf is greater than or equal to 39, find the value of k. Okay, first let's write gf. What is it? Let's find it out. So gfx, that's what it means. Gf means gfx. In place of g we will write f. So g is this, so gfx will be 5 is the parent function. In place of x, we will write fx, the whole of it. So let me put a bracket here. 3x minus 2 square plus k. And then after that we have minus 1 also. Yeah. So let's try to simplify this now. So 5, 3x minus 2 square plus k plus 5k rather. Yeah, because 5 will multiply with both. Minus 1. And since they have given us the range, let's convert this to quadratic, vertex form of this. So let's do what? I do not want this 3 here, so I'll divide here by 3, divide here by 3. That means I have to multiply outside by 3 and not 3. It will be 3 square because this 3 is also being squared from here. So it will be here. So outside we'll have 45. 9 times 5, 45, 3 and 3 cancel. It will be x minus 2/3 square plus 5k minus 1. This is g of x. Now, since this is the vertex form, and we know that the vertex, in vertex form, this gives us the x coordinate of the vertex, which will be 2/3. So let's say, is it opening up or down? Is it opening up? Because 5 is positive, our graph is opening up. So the x coordinate is 2/3. Y coordinate is 5k minus 1. Okay. And they are saying that the range is 39. That means this y value is actually 39. Then only it is possible that this is y value and the range is above 39. That means this y value is 39. That means 5k minus 1 is 39. 5k equal to 39 plus 1, which is 40. So k will be 40 divided by 5, 8. We got 8. Let's move on to the next one. For this value of k, determine the range of the function fg. So we'll substitute this here in this one. So 3x minus 2 square plus k. Let me write here. Fx is 3x minus 2 square plus k, and in place of rather k, I will write 8 now. 3x minus 2 whole square, that's what it is. 3x minus 2 whole square. Okay, and gx is 5x minus 1. Gx is 5x minus 1. Alright. Now, I want fg now. So, in place of x here, we will write gx. So, f gx will be, let me put this bracket, 3, this one. But in place of x, I will write 5x minus 1 now. So, 5x minus 1 minus 2 square plus 8. This becomes the new function, which is fgx. Okay, let me simplify this. It will become, now we can go back to the same function, 15x minus 3 minus 2 square plus 8. Yeah, minus 3 minus 2. Okay, so it comes out to be 15x minus 5 square plus 8. And now again we have to get rid of this 15. So we will divide here by 15, divide here by 15, but outside we will have to multiply by 15 square. Yeah, so 15 and 15 cancel out. So 225 x minus 1 over 3 square plus 8. So now y coordinate, because they are asking range again, y coordinate did not get changed because of this manipulation. So even if you don't do this, it will be okay, but it's a good habit to write the vertex form in a proper way. So now we can say that the range of f gx or fg, that's right, fgx, okay, is equal to fg is greater than, because it's positive again, it's positive, it's opening up, so greater than equal to 8. That's the range. C is also there. Function h is defined for all real values of x and is such that GHX is equal to 35x plus 19. GHX is equal to 35x plus 19. Find an expression for G inverse x and hence or otherwise find an expression for hx. So let's find G. What was gx? Let's go back. What was gx? 5x minus 1. We want to find its inverse. Since it is linear, it will be easy to do that. So I will replace gx by y and it becomes the function. Now if I inverse here only, x becomes y and y becomes x, and that's what I have to isolate now. This y I have to isolate to get inverse. So 1 will come here, I'll get x plus 1 equal to 5y, then I'll divide both sides by 5 so that this 5 gets, so y is equal to x plus 1, which becomes our inverse. G inverse x equal to x plus 1 over 5. Now since it is G and this, we know that G inverse x will be equal to x. That means, or G inverse G x equal to x. So if I apply G inverse to the whole of it and G inverse to the right side as well, I can use this one, where G inverse and G will be neutralizing each other, will be remaining left with hx. And G inverse of this, that means in this G inverse, we'll substitute 35x plus 19 in place of this x. So it will be 35x plus 19, then we have plus 1 over 5. So hx comes out to be 35x plus 20 over 5. Now we can cancel directly or take 5 out. 7x plus 4 and 5, and purpose is to cancel. Our hx finally becomes 7x plus 4. Diagram shows a circle with center minus 4, 5. So minus 4, 5 is the center here. And radius is minus, so square root 20. So let's say this is square root 20 center. Sorry, the radius. The circle intersects the y-axis at A and B. The size of angle ACB is theta radians, ACB. Find the equation of the tangent to the circle at minus 6, 9. So if it is minus 4, minus 6, 9 will be somewhere here. So we have to find the equation of the tangent at this particular point. Okay, so we should know that a radius, if this is radius and this is tangent, they always make 90-degree angle, right? So the plan is that the equation of tangent, which is a line, an equation of any line for that matter, is y minus y1 equal to m x minus x1, where x1, y1 are the points where the tangent is there. So minus 6, 9. We'll substitute those values here. Y minus 9 equal to m is unknown, so I will keep it blank for the time being, minus 6, which will ultimately become positive. Okay, so this blank space is to be filled by the gradient of tangent, and directly we can't get it. First we'll find the tangent of this radius, and then because they are 90 degree, we can just negatively reciprocate it and we'll get it. So gradient of radius. And what is the formula for any gradient? y2 minus y1. Let me take 9 as y2. y2 minus y1, which is 5 here, over x2 minus 6 minus 4, okay, which is positive. So which will be 9 minus 5 is 4, and minus 6 plus 4 is minus 2, which is minus 2 is the gradient of this radius. So the gradient of the tangent becomes the negative reciprocal of minus 2, which is positive half. And now, do we need in any format? No, they have not written, so we'll just cross multiply 2 here. 2 multiplies with y minus 9, it becomes 2 minus 2y minus 18 equal to 1 does not make any difference here, so x plus 6. So we can write, we can bring everything to the left side. So 0 equal to x minus 2y plus 18 plus 6. And if I exchange their places again, so it will be x minus 2y plus 24 equal to 0. This is the equation of the tangent, sorry. Okay. B part. Find the equation of the circle in the format of this equal to 0. Equation of any circle. Since the circle is like this, bad circle, the center is minus 4, 5, and radius is square root 20. So equation becomes and xy is any point on the circle, which will be this x and this y. So we will write what? X minus, by distance formula, x minus minus 4, which is plus 4, square plus y minus 5 square equal to square root 20 square. Alright, so square root and square root cancel out here. So if I expand this, it will become x square, a plus b whole square root, basically plus 16 plus 8x plus y square plus 25 minus 10y, and let me bring 20 also to the other side, minus 20 equal to 0. So x square plus y square, that's what they wanted. Ax next, which is 8x, then by, which is minus 10y, and then c will be 16 plus 25, 41 minus 20, 21. This is the equation of the circle. Alright. Find the center theta correct to 4 significant figures. Find the value of theta. Okay. How come? Okay, this is theta. So here we can, let's say this is, we know that at y-axis, x is 0. So let's call it 0 A and 0 B, right? This will help us to find the angle theta. Okay. Find the theta correct to 4 significant figures. So now we have the equation, and let me take the help of this one. So circle again. This is 0 A, this is 0 B. What is common between the two? That the x is 0. So in place of x, I will put 0 so that I can get B and A. So substitute x equal to 0 in the equation. So 0 square plus y square plus A times 0 minus 10y plus 21 equal to 0. This is gone 0. Gone 0, we get a quadratic equation now. Equal to 0. Now we can find y by different methods. I'm splitting the middle term. Y square, because 21 has factor 7 and 3, so I will write 7y and 3y plus 21 equal to 0. Y minus 7 minus 3y minus 7 equal to 0, and that becomes y minus 3 and y minus 7 equal to 0. That gives us two answers, y equal to 3 and y equal to 7, and they make perfect sense. So this becomes 0, 3 because this is lower. This becomes 0, 7, which is higher. Now, what we needed to find out? Theta. So theta was at the center, right? We know this is square root 2, 20 rather, square root 20, and we can find this in this triangle. If I connect with center, the chord is always divided into two equal parts because it's an equilateral triangle, right? So what was in, these are A and this was B, correct? So what will be the length of AB? By distance formula we can find it, or rather there's no need to find it, we already know, because the x coordinate is 0 for both, the difference between them is 4. That means this length is 2 units and this length is also 2 units, because clearly we can see a difference of 4 here. 7 and 3, the difference is 4. So now I can find angle with the help of trigonometry. 20 here, 2 here, and this was theta, so let's call it alpha, which is half of theta. Yeah, so sine alpha will be equal to opposite over hypotenuse. So alpha will be sine inverse 2 over square root 20. Let me see how much is that in radians, because they said that theta is in radians somewhere. Theta radians, can you see? So we have to use radians, we can't give answer in degrees. And by the time I do this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 0.463, and we want 4 significant figures. So alpha is 0.4636, but theta, which is 2 times alpha, will be equal to 2 times 0.4636, which will be 0.9272. Four significant figures. We got our theta as well. There is a D part also. Find the perimeter and area of the segments shaded in the diagram. Okay, we have to find the area of this segment. So what my plan would be, let me show it with different colors. I will find the area of this sector, because I know the this angle theta now. I can find the area of this sector and then subtract the area of these two triangles, or the whole triangle. I can find the angle of whole triangle. That is my plan. Okay, so the area of the sector minus area of triangle, that will be my plan. So area of the shaded region first. Okay, they're saying perimeter as well, so we'll find area first. Area of the shaded region will be area of the sector minus area of triangles. So area of the sector is half r square theta. Area of the triangle is half AB sine C. So if I draw that again, this is theta. So the area of the sector will be this, which is half r square, square root 20 is the radius, and theta we just got 0.9272. Yes. Okay. Minus half times AB are the two sides of the triangle, which is square root 20 here, square root 20 here. So I will write square root 20 times square root 20 sine, the angle between those two sides is theta, sine 0.9272. Okay, so it will become complete 20. Can you see? So 2 divided by complete 20 will be 10 times 0. This will be 9.272 minus. This will also become complete 20, and that will be 10 sine 0.92 sine 9272. So let me find 10 times 0. Is equal to 8, complete 8, and that comes out to be 1.272 units square is the area of the shaded region. Now, perimeter. For perimeter, we need to find this side, which you already know is 4. So 4 plus, we need to find the arc length, and arc length is r theta. Just multiply the angle with the radius, you get the arc. So arc plus 4 will be the answer. So 4 plus r is square root 20, and 0.9272 is the angle. Let's see what we get. By the time I'm doing this, I would request you to like this video, share with your friends, and subscribe to Math United. What I'm getting here is 4 plus 4.146. So let me write 1.15. So the perimeter becomes 5.15 units. We got the perimeter as well as area of the shaded region. Question number 11 talks about the diagram that shows this graph of this function, okay, where x is greater than 0. The curve crosses x-axis at a and b and has a minimum point M. Find the exact coordinates of M, exact coordinates, okay. So M is a minimum, we can see stationary point. So for any stationary point, dy over dx, the differentiation has to be equal to 0 because the gradient of the tangent at that place is 0. It's a horizontal line, okay. So I'll differentiate this function now. Dy over dx is equal to, if I differentiate this, minus 2/3 comes and becomes a coefficient. Then we have 2 already there, and then it goes down by 1. Similarly here, minus, there's a minus here and there is minus here. In the exponents it becomes positive 1/3. Then we have 3x to the power minus 1/3 minus 1. And differentiation of 1 is 0, so we will not write it. So what do we get here? Minus 4 over 3 x to the power minus 5 over 3 plus 3 and 3 cancel, x to the power minus 4 over 3. Minus 4 over 3. Alright, this is the one. Now, this has to be equal to 0 for a stationary point. Now, we can see that both of them have x to the power something. Which one is smaller out of these two? Which one is smaller? Minus 5 over 3 or minus 4 over 3? Minus 5 over 3 is the smaller, so we'll take it common. So x to the power minus 5 over 3 is taken common, and let's write here minus 4 over 3 is the only number left here. Then plus, what is the difference between these two? Minus 5 over 3 plus 1 over 3 is equal to minus 4 over 3, isn't it? That means this minus 4 over 3 has 1 over 3 extra, right, than minus 5 over 3. So if I write x to the power 1 over 3, that will be good. right? Now, if this is equal to 0, I'll equate both of them equal to 0. So x to the power 5 minus 5 over 3 equal to 0. That gives us x equal to 0. That means there is a stationary point somewhere here also, which we do not want. This is the one which may work. So minus 4 over 3 plus x 1/3 is equal to 0. So x to the power 1/3 is equal to positive 4 over 3. To get x, we will cube it and cube this also. So x comes out to be 64 over 27 positive, and that makes sense. It's positive, right? That's the x coordinate. Find the exact coordinates of m. That means y is also to be found out. So for y, we will substitute this into the equation here. So 2 and x is 64 over 27 to the power minus 2/3 minus 364 over 27 to the power minus 1/3 plus 1. So let me do it mentally. You can use calculator. So minus 2/3, to make it positive, I'll reciprocate this. So it will become 27 over 64 positive 2/3 minus 327 over 64 positive 1/3 plus 1, which is 2. That becomes 3 square 9 over 16 minus 3 times 1/3 is 3 over 4 plus 1. So 18 over 16, let me rather cancel it. 9 over 8 minus 9 over 4 plus 1, which will be 9 minus 18 will be minus 9 plus 8 minus 1 over 8. Let me see again. Minus 18 over 8, so minus 9 over 8. So minus 1 over 8. That's the y coordinate. So the m's coordinate become 64 over 27, comma minus 1 over 8. Next part. Find the exact area of the region bound by the curve and the line segment AB. This area they're talking about. Of course, this area is going to be negative if we use integration. Yeah? And let's get ready for that. We will just make it positive. So 2 to the power minus 2/3 minus. Okay, so we'll integrate for area under that curve. 2 to the power minus 2/3 minus 3 to the power 3x to the power minus 1/3 plus 1 dx. From where to where? Do we know a and b? No, we don't know a and b. So we need to find a and b. Okay, that means for finding a and b, we have to find the x-intercepts of this particular function. So 2x to the power minus 2/3 plus minus 3x to the power minus 1/3 plus 1 equal to 0. Let's assume that x to the power minus 1/3 is equal to t. So this equation becomes 2t square, because it's double of this, right? So it will become t square minus 3t plus 1 equal to 0. So, okay, splitting the middle term, 2t square minus 2t minus t, nope, yes, it's okay, plus 1 equal to 0. So 2t, t minus 1 minus 1, t minus 1, 0. So t minus 1 and 2t minus 1 equal to 0. This will give us t equal to 1. This gives us t equal to half. However, t was my creation. So I'll go back to this one again. So x to the power minus 1/3 equal to 1. X to the power minus 1/3 equal to half. So no matter what, x will come out to be 1. But what about this? I have to give it power minus 3. Yes, so that this minus 1/3 and minus 3, they become 1, which gives us x. And if I put 1 over 2 to the power minus 3 in my calculator, I should get 8. This becomes my limits for this definite integral, 1 to 8. And now I'll find the area. So I'll first integrate this one, so it will become 2x to the power minus 2/3 plus 1 divided by minus 2/3 plus 1. This is how we integrate this, right? 3x to the power minus 1/3 plus 1 divided by the same exponent, minus 1/3 plus 1, plus different integration of 1 will be x, and then c from 1 to 8. So 2 remains 2, x to the power positive 1/3 divided by 1, and I will not write 1/3, I will write 3 at the numerator, minus 3x to the power 2/3 divided by 2, and I will multiply here by 3, plus x plus c from 1 to 8. So now I'll substitute 8 and 1 and simplify this also. It becomes 6x to the power 1/3, right? So I will write 6, 8 to the power 1/3, because 8 is I'm replacing here. Minus 9 over 2, 8 to the power 2/3 plus 8 plus c, minus, I substitute 1 now, 6, 1 to the power 1/3 minus 9 over, and actually, yeah, it's positive, no? Yes, okay. Positive, yeah. 1 over 2/3 plus 1 plus c. First thing first, c will get cancelled in both because of the negative in between. So this gets me what? 2 times 6, 12 minus 4, yeah? 2, 4, yes. So 36 over 2, which is 18. 4 times 9, 36 over 2, 18 plus 8 minus 1 to the power anything is 1, so 6. This minus and this minus will make it plus 4.5, we can write. Yes, and this plus and this minus will make it minus 1. So positives are 12, 20, 4.5, 24.5. Negatives are 18, 24 and 25, minus 25, which will be minus 0.5. Obviously it came out to be negative as we expected, so we can say that the area of the region is 0.5, not negative anymore, because it is below x-axis, that's why it was negative, and we have absoluted it, that is the area, 0.5 units square. This concludes my video of solution video of paper 12, February March 24. If you liked it, please give it a thumbs up, share with your friends, and subscribe to Math United. Thank you so much for your time.